Have you ever found yourself stuck in an endless back and forth with AI, trying to get it to understand your project? What if I told you there's a better way to communicate with LLMs that drastically improves results, saves time, and might just change how you build software forever? Today, we're diving into contextual prompting, the game-changing approach that's transforming how developers work with AI. Traditional prompting often feels like explaining your entire project from scratch over and over again. Look at this common workflow. We're asking an LLM to add authentication to our Node.js app, but we're starting with zero context. The LLM has to guess what our project structure looks like, what dependencies we're using, and our coding style. This leads to generic responses that require extensive modification, or worse, solutions that don't integrate properly with our existing code. There's a more effective approach to this. It's called contextual prompting. Contextual prompting revolutionizes the entire interaction process. When you provide your language model with relevant context up front, you establish a shared foundation of understanding before diving into specific questions. Let me walk you through how this works. Consider implementing an authentication system in a Node.js application. The first crucial step is breaking down this complex task into smaller, manageable components. This approach helps minimize AI hallucination and establishes clear objectives for producing high-quality results. In this case, we begin by asking the AI to brainstorm the architecture of the authentication system. Once we're confident with the architectural design, we'll proceed step by step, implementing sign-up functionality, then login, logout, and so on. To implement this methodology, we create a project containing our existing code files, best practices documentation, and specific instructions for the AI. We then initiate our first chat focusing on generating an authentication system architecture plan. After finalizing the architecture, we add this plan to our project's knowledge base and create a new chat specifically for implementing the sign-up functionality. This iterative process continues as we add each completed component to our project base and build upon it. Let's explore how to accomplish this using various AI platforms. ChatGPT offers a feature called Projects, though it requires a paid subscription. This feature allows you to create projects, add files to your knowledge base, and provide specific instructions for the AI. You can then engage in focused conversations within this context. Claude offers similar functionality, again with a paid subscription, allowing you to create projects and maintain a knowledge base with relevant files. However, we've discovered an excellent alternative for this workflow, Prism Harmony. This platform implements the exact organizational structure that makes contextual prompting incredibly straightforward. Let me demonstrate how it transforms our development process. Visit prismharmony.com to see how it serves as a unified hub for all your work. Instead of managing multiple subscriptions, you get comprehensive functionality under one roof with workspaces and more. The platform operates on 3 distinct levels: workspace, topic, and chat. Take this example of a YouTube channel workspace called Tech Simplified. Within this workspace, you'll find multiple topics like audience engagement, video production, research, and more. Each workspace allows you to specify your preferred LLM model, set workspace-wide instructions, and maintain a knowledge base. Their pricing structure is straightforward. 100 credits cost $1, and these credits work with any LLM of your choice. You can start exploring with 50 free credits. Let's create an account. After signing up, you'll create your first workspace. You can either quick start with their pre-built templates, click the question mark to learn more about them, or create a custom workspace by clearly defining your requirements and letting the AI generate the setup for you. Let's try creating a Life Goals Navigator workspace. Perfect. The AI has generated a workspace with 3 topics: goal setting, habit building, and reflection growth. We can now choose our preferred model. They support various options. Let's select GPT-4 Mini, or perhaps the latest O1 Mini model, which offers great value for money. Next, we can set workspace instructions. For instance, specifying that the AI should act as a professional life coach and provide frameworks for better understanding. The knowledge base section shows suggested core concepts and best practices. You can enhance this further by adding your own documents or uploading relevant files. Exploring a specific topic, you'll notice each one has its own model settings, instructions, and knowledge base. Let's create a new chat within this topic. Watch how the AI responds to our message, drawing from both topic and workspace knowledge to provide relevant guidance within our framework. Notice how it suggests reflecting on our current situation and setting goals, asking specific questions like, "What goal would you like to focus on today?" while providing options and next steps. If you're not satisfied with a response, you can easily switch to a different model, like Google 1.5 Flash, and get a fresh perspective based on your knowledge base. Let's explore how to create our own workspace. Click on New Workspace. You can either generate it with AI or create it manually. Let's name it Node.js application. For this workspace, we'll use Claude 3.5 Sonnet for coding. Let's add some instructions, which we'll call core instructions. These are crucial guidelines that the LLM will follow when responding to queries about this Node.js project. Any conversations within this workspace will adhere to these rules. Now let's add our knowledge base. We'll start by adding a master plan for our project, which helps all topics understand the application's purpose. As you can see, it's a straightforward Node.js application that communicates with a Telegram bot. We covered the bot setup in our previous tutorial. Feel free to watch it to learn how we receive messages from users and send them back. Within this workspace, let's create a new topic called authentication system. Here we can override the default model for this specific topic if needed. Let's add some topic-specific instructions that we'll call topic instructions. These guidelines ensure production-ready code following specific patterns and best practices. Now for the interesting part, topic knowledge. We're uploading our existing code files as context, giving the LLM a complete understanding of our application architecture. Our application is a simple Node.js setup with express routes, directing all traffic to our handler. We're using Axios for API calls to communicate with the Telegram bot, including a header handler function and a Telegram controller managing message handling, sending, and chat enablement. Let's create a new chat within this topic. We'll stick with Claude 3.5 Sonnet as defined in the project. Our query to the LLM is, we need to add an authentication system for the application. Before writing code, let's brainstorm the architecture and functionalities. Notice how adding "please let me know if you have any questions" changes the LLM's response. Instead of immediate implementation, it first seeks clarity about user management, authentication scopes, integration requirements, and security considerations. After answering these questions, the LLM provided a comprehensive architecture using Supabase, as mentioned in our requirements, for user management. It outlined the database schema, application flow, and necessary layers. It also provided a clear, phased implementation plan covering user authentication, role management, and bot integration, along with a detailed code structure. Let's save this as authentication architecture in our knowledge base. Now, creating a new chat, we can ask about implementing Phase 1. Again, we'll prompt the LLM to ask questions first. The LLM responded with authentication-specific questions. After addressing these, it provided detailed implementation plans, including Supabase configuration, environment files, and necessary code updates. It understood our existing error handler and extended it appropriately, creating new files like API error handlers and updating helper.js. We can now implement these changes by copying the files to their specified paths. For subsequent phases, we'll add these files to our knowledge base and continue the implementation process. For reference, this entire conversation cost approximately 11 tokens, about 11 cents. Token charges are based on our LLM interactions, and you can purchase additional tokens through their various pricing plans, starting from $5. Okay, the approach we discussed works well for smaller projects. However, as projects grow larger, it becomes challenging to feed the entire codebase to LLMs. This is due to context token limits and potential cost implications. Let's explore a better alternative using our blog starter Next.js application as an example. Our application has multiple routes, one for displaying posts and another for creating them. It also has various components. Currently, posts are stored in Markdown files. The UI shows all posts from these Markdown files, allows users to read them, and create new ones through the new post route. Let's say we want to add a save draft functionality to the new post page. Instead of publishing directly, users should have the option to save their work as a draft. There are different approaches to implement this. The first approach would be giving the entire code base to LLMs. While this works, it's not efficient given the number of files and complexity. Looking at the new post functionality, we can see it mainly depends on header and container components, React's use router, and use data. We don't need to provide the entire code base for LLMs to understand, just the relevant context for this specific feature. Instead of manually selecting relevant files, I've created a shell script with LLM's help. This script takes a file path as input, analyzes its dependencies, and copies the necessary files to an AI training set folder. Let me demonstrate how it works. For our new post functionality, I'll copy the path and run the script using the command. Notice how it created an AI training set folder containing only the essential files, the new post component and its two dependencies from the components folder. Now let's go to our Prism Harmony workspace. I've set up a workspace called Let's Build Together blog with a front-end application topic. The instructions specify acting as an expert Next.js architect along with best practices. To build our feature, we need to provide context to the topic knowledge. Let's upload the files from our AI training set, new post TSX, header TSX, and container TSX. We're now providing just enough relevant information for the LLM to understand the context. Before getting the LLM's response, we encourage it to ask questions if anything is unclear. This is crucial as it prevents hallucination. The LLM will seek clarification rather than make assumptions. After answering the LLM's questions, we received comprehensive changes including a new handle save function, draft parameter handling, and a new button implementation. It also suggested creating a draft directory and provided guidance for future features like a draft management page. One pro tip: when copying LLM responses, be selective and only copy the relevant code chunks. Sometimes it won't include all the file changes. After implementing these changes and creating the drafts folder, we can successfully save drafts. For the draft listing functionality, we just need to provide the API route and some context about how existing drafts are structured. Finally, here's an important tip. When copying dependent files to the AI training set, include a comment indicating the file's hierarchy. This helps the LLM understand your code structure and provide more accurate suggestions aligned with your project's organization. Thank you for watching. Don't forget to subscribe to Let's Build Together for more programming tutorials and projects.